Hi, welcome to What is CNN, and today I will take you through what are convolutional neural networks in less than 10 minutes. My name is Rohit Agarwal. I am an award-winning data science leader, PhD scholar, and a Kaggle 3x expert. Before we talk about CNN, let's talk about images. If I was to ask you, what do you see in this? Then the answer depends on the question that I'm asking. If the question is one of image classification, then the answer could be classroom, professor, lecture, blackboard, or an educational institution. The question is of object detection, and the answer could be drawing a bounding box across the professor, across the blackboard, or across the clock. If the question is of captioning, then the answer could be simple as professor writing on a blackboard. If the question is of face recognition, then the answer is identifying the name of the person represented in the image. If the question is of optical character recognition, then the answer could be identifying if there are any digits or numerals or characters in the image and identifying what do they represent. So as we can see that it's a model that takes an image as an input and throws the relevant output. Let's call this function as a CNN model. CNN model will take an image, do a bunch of computations, and then give us an output corresponding to the question that we ask, which is the question for which the model has been trained on. Now, how does it work? First, let's do a quick recap. In what is machine learning and how does it differ from traditional programming? In traditional programming, we throw data into a set of predefined rules and we get an output. In machine learning, we throw a bunch of training data at an algorithm to get a model which is trained. Then we throw another set of data, let's call that as test data, into the same trained model and we get an output which corresponds to the test data that has been thrown into this trained model. And this is what makes machine learning different from traditional programming. Now, what's deep learning? Now, machine learning has multiple algorithms: linear regression, logistics regression, support vector machines, k-means, k-nearest, decision tree, naive Bayes, principal component, linear discriminant, and so on and so forth. Neural networks is also one algorithm under the entire umbrella of machine learning, and this specifically is referred to as deep learning. The reason why that is because neural networks are really adept at solving large-scale problems. Now there are multiple variants of neural networks like feed-forward neural networks which are used to handle structured data, typically recurrent neural networks typically to handle sequential data, convolutional neural networks typically to handle images. Now, why is convolutional neural networks best designed to handle images? Let's look at that in a bit more detail. But first, we have to answer why are images special? Now, spatial invariance. What does that mean? If I move this image slightly up or down or right or left, the meaning of the image will remain the same, as in the answers that I expect out of the image will remain the same. Hierarchically, if I zoom in slightly or zoom out slightly, again the meaning represented by the image will remain the same. Large size. The way images are represented is by storing pixel value across rows and columns. Typical phone camera captures around 12 megapixel worth of 12 megapixels. That means that a single image contains 12 million pixels, and each pixel represents the brightness in 3 channels, typically red, blue, and green. So that means already there are 36 million brightness values represented to store a single image. And that is very large data. Also, Images are unstructured data. What does that mean? Each of the pixel values in any of the channels represent brightness for that specific channel, and this is the same for any pixel anywhere in the image. Now this is different from, say, sales data, wherein we might have one feature as sales, another as units sold, third as region, fourth as seasonality, and so on and so forth. Hence, each feature in an image represents the same thing, and hence it's called as an unstructured data. Now let's jump into how does CNN work. This might look a bit intimidating to you, but just focus on input and the output for a moment. For an input, we pass in the image, and as an output, we get the output that we are expecting. In the middle, we see that there are multiple layers, and each layer is drawn from the previous layer via some operation. The operation could be convolution, or it could be subsampling, or it could be something else as well. What's convolution? Let's understand that in a bit more detail. Convolution operation contains a kernel of, say, size 3 cross 3 that identifies a similar sized submatrix in the input and multiplies each cell of the kernel with a corresponding cell of that submatrix, and then multiplies them and does a simple addition. That value is stored in the output layer, and then this kernel is scans the input via a sliding window approach. For example, in this case, we see that these numbers are getting multiplied and then summed up, and then the sum is represented in the output layer. And then this, as a sliding window, slides across the input image to be able to populate the next layer. Now, another type of layer is subsampling or pooling. This is typically designed to reduce the size of the image. If we see that the large image size was one of the concerns that we had to face. So in pooling, what we do is we divide the image into smaller sub-images, and then via a certain method, we populate the next layer. There are two major types of pooling: max pooling and average pooling. In this example of max pooling, we divide the image into 2 cross 2 sub matrices, and then for each submatrix we identify the largest number and we use that to populate the next layer. This helps us reduce the size of our layer. Now if we look at this image again, then we'll understand the operations that are applied from one layer to the other layer to be able to finally get the output. Now, as you can understand, there are many hyperparameters in this, including the number of layers, the type of operations to be applied, size of the kernel, and type of subsampling or pooling to be done, and so on and so forth. And as such, there have been a few architectures, which is just a combination of these hyperparameters, that have been seen to give better performance and have perform better on unseen data as well. Starting from 1998, where Linnet was one of the first convolutional neural networks, till all the way to 2019, wherein EfficientNet is the typical state of the art. There have been multiple attempts at identifying the most generalizable architecture of CNN, and the performance of each year has been much better than the performance of the previous years, indicating that there is still a large amount of scope to identify even better architectures. Thank you. Hope you had a great session. Please consider this as a starting point and wish you all the best in your computer vision journey. Thank you.